Hello everyone. In this video, we are going to see the closed loop simulation of buck converter with the digital controller. In the last video, we have seen the closed loop simulation with the digital controller, but in this, we are going to see simulation of closed loop simulation of buck converter with the digital controller. To see how to construct the buck converter using the state equations and to see how to use the analog controller to control the output, kindly refer the description where the links are given. Now, this is the model, closed loop model, which we have constructed for with the analog controller in the last video. Now we are going to have the closed loop simulation with the digital controller. So here, what we are going to do is that this is the analog controller. Now let us click on this analog controller. So you will be having this controller block. There we have the two options: continuous time and discrete time. If we choose continuous time, that will be your analog controller. And in the analog controller, we have taken Kp as 0.2 and Ki as 40. The same Kp and Ki values we can keep for digital also. And instead of continuous time, we have to choose discrete time. So once we choose the discrete time, we will be having these parameters which are appearing here. So here, the sampling time, the default sampling time, it is there in the box as -1. So to start with, let us take the sampling time as 10 microsecond and check whether we are able to control the output voltage. Now, in the digital controller, we will be having the integration methods. There are three methods for integration methods: forward Euler, backward Euler, and trapezoidal. So let us first try with the forward Euler and check for the result. So once we choose all these things, we can apply and close. And now we will run this model, keeping the input voltage at 24 volt. The change which we are going to incorporate is that the load resistance value, we are keeping it as 3 ohms initially, and the final value, we are going to take it as 5 ohms. So let us run this simulation, and the change of resistance, it is taking place at the step time of 0.03. So now we can run this model and check for the output voltage waveform. So we can see that once the simulation is started, it takes some time to reach the final value of 12, set value of 12 volts. And at point 0.3, we are introducing the change in the resistance value, where the 3 ohm resistance is now changed to 5 ohm resistance. So once the change is taking place, some oscillation, we are having some oscillations, and after some time, it reaches the set value of 12 volts. We could see that with the digital controller, we are able to control the output voltage, even the load resistance is changing. Now we can try this with another integration method. Instead of forward Euler, we can choose the backward Euler and check what's happening. So again, this is the waveform which we got with the backward Euler. Even with backward Euler, we are able to get the set value of the desired output voltage. Now we can change the method, integration method, to the trapezoidal method. And again, we can run this. So even with the trapezoidal, we are able to control the output voltage. So there will be slight difference in the rise time or overshoot or something, but the final control is happening in all the three methods of integration. Now we can, instead of giving a constant voltage, now we can choose a step change in the input voltage. Let us take the initial value as the given voltage, which is 24 volt, and final value we can change it to 34 volt, and step time we can change it to 0.03, and let us now choose the resistance value at the constant. Resistance value we can keep it as constant. So 1 at 3 ohms. So 1 by 3 I'm giving here. And let us check whether we are able to get the control for all the 3 integration methods. Let us begin with forward first. So here again, with the change in input voltage also, we are able to control the output voltage at the set value of 12 volts. The set value is given here. Now we can change the integration method to backward and see the result again. So here also we are able to control. Now again, we can check for the trapezoidal integration method. So again, we are able to control the output voltage to the desired value of 12 volts. So in this video, we have seen the closed loop control of the buck converter, which is constructed with state equations, and we have seen the closed loop simulation with the digital controller, and we have seen the output voltage for three different integration methods: forward Euler, backward Euler, and the trapezoidal methods. Thank you for watching this video. Thank you.